For this lesson, I'd like to focus on some exponent rules. We've seen this one before, this idea of x to the a times x to the b. What is this equal to? But just to look at this one more time, as an example, x squared times x cubed. The definition of an exponent means x squared is x times x, and then x cubed is x times x times x. So this first one was write 2x's. The next one was write 3x's. So altogether, you have 5 in a row. So said another way, I'm really focusing on the exponents of 2 and 3. They sum to 5. And that's precisely what this rule is up here. You can simply add the two exponents together. So I'd like to try this rule in example 1. So let's start by multiplying negative 4 times x to the 4th times negative 7 x to the 12th. So for any expression like this, I would start by multiplying the numbers together. So this negative 4 times a negative 7. That's got to be a positive number, positive 28. But that leaves us with an x to the 4th and an x to the 12th. So here it looks exactly like this expression here where you have an x times an x to two different powers. So at this point, we can simply copy down the 28 and add the 4 and the 12 together to give us a final answer of 28 times x to the 16th. Now obviously your expressions could be more complicated. You could have several of these in a row, but let's take the same approach where, okay, I'll scan across this expression. We're multiplying this all together. We could start by dealing with the numbers and then look at each individual variable as we go across. So to start with, okay, we have a negative 2 times a 1/8 times a 12. I'm going to think about this one separately, just kind of like think about, well, what happens if I multiply 2 over 1 times 1 over 8 times 12 over 1? Maybe just simplify that number separately and then put it back into the problem. Let's see. 2 goes into itself once and it goes into 8 4 times. But 4 goes into itself once and into 12 3 times. The entire first value is going to be negative 3. So I'm going to start there. The product of negative 2, 1/8, and 12 simplified to just negative 3. Notice that everything canceled to a 1 except for this 3 that was left over that came from the 12. As a second step, I'm going to scan this expression for the variables. And I see that there's two variables now. There's both x's and y's. I'm going to write all of the x's in a row. So we have this x, an x cubed, and an x to the 6th. So I'm just going to list all of those out. An x cubed, and an x to the 6th. And really that first one is x to the first power. I'll then do the same thing for the y's. We have y and y cubed. I'll put those next to each other. That's really y to the first and y cubed. And now I can just start adding all these pieces together where, okay, for these first two, that's 4 total x's. There's going to be 6 more for a total of 10 x's right here. This is negative 3x to the power of 10. If I then look at the y's, I have 1 here, there's 3 more here for a total of 4. And this is the final answer, negative 3 times x to the 10th times y to the 4th. So we'll focus on one other rule in this section. So what happens if I divide two x's to different powers instead of multiplying them together? So actually dividing x to the a and x to the b. For this rule, I again want to explain it where, well, what if it was something like x to the 5th divided by x squared? What does this equal? X to the 5th means x times x times x times x times x, all divided by x squared, which is x times x. I can cancel, let's say this x with this one, leaves like a 1 left over. I can then cancel this x with this, So there's, again, just a 1 being left over. And my final answer is, well, this is just 1, and this is just 1. So it's x times x times x. So that is x cubed. When we're dividing, we're subtracting the exponents. So I look at this problem as, oh, well, 5 here and 2 here, when I divide it, leaves me with just 3 at the very end, or 5 minus 2 is 3. This is our general rule for an expression like this. X to the a divided by x to the b is x to the a minus b. So I'd like to apply this idea now in example 2, where I want to simplify the following expression. So really we could treat this as, I want to divide these two pieces, this 4x to the 5th y squared by negative 2x cubed y. To do this, I'm going to break this up into 3 fractions. I'll put the numbers together, I'll put the x's together, and I'll put the y's together. And I'll put an exponent of 1 in that denominator, so y to the first. If I start with the fraction with the numbers, that's 4 divided by negative 2, so it's a negative 2. For the second fraction, that's going to be x to the 5 minus 3. And for the last piece, it's going to be y to the 2 minus 1. If I simplify this, I get negative 2x squared y to the first. And we can really just leave off that exponent of a 1. So we have a final answer of negative 2x squared y.